Okay, so I hope that first video I got you to watch gave you a bit more information about kind of why we learn statistics and how it's this snapshot of like life and worlds and people and groups to help us understand what's kind of going on in the world, and it kind of allows people to make decisions and get certain information. Like I've said before, statistics is one of my favourite areas, if not my favourite area of maths. For me, it makes a lot of sense. The results that we get, you kind of can go, oh yeah, that feels about right, that sounds about right. And it's something that we do see on a day-to-day basis, probably something, an area that you probably see more than you even realise. So like, for example, here I just grabbed a couple of adverts off of YouTube and did some screenshots, and you can see that like when you watch TV, so next time you're watching television, you're watching adverts, have a look at the information that's shown down the bottom of those tabs. So any really kind of adverts like insurance, or even like kind of these ones I'm showing are cosmetics ones. So let's have a look at this L'Oreal advert. So if you look down the bottom here, it says that they did a survey of 2,983 women, and later on in the advert it tells you over 73% agree, so which was 356 women of that survey. So they've had to do a survey to be able to say certain things about that product, and these are all the kind of statistics you look like. Okay, similarly, here is another one, Nivea for men. So they've done a survey. I don't remember exactly what it said, but 71% of 164 men agree. Statistics is, I find, really interesting. It's an area that actually a lot of people, mathematicians, don't like, because obviously you can use statistics to your advantage in certain ways. You can present things you can use one particular graph to get your point across, or you might use another one because it might get your point across a little bit more. So for example, for this one, I mean, really 164 people isn't that many. Yes, 71% is a big chunk of them, but that's not really that many if you think about it. So for example, in this one, all this would mean was kind of 116 people agreed and 48 people didn't. I mean, that's actually a fairly big chunk of people who didn't actually agree for everyone. But, however, when we word it in this way, perhaps makes it sound, and this is the big value. You see the 71% and you think, brilliant, but you don't actually think, well, actually, first of all, 164 people isn't really that many to survey, and actually, if you think about it, when we look at the numbers, there's not really much of a difference, I suppose. Still a big difference, but is it really that much noticeable? Anyway, that was a bit of an aside. So today we're going to look at another way of presenting data, which is pie charts. These are ones you may have seen before. A lot of the time they're used in TV programs and in newspapers, because they're good at showing you the way things are in comparison with others. So here's just a couple of examples of pie charts. So here's one where I'm sure it's something that kind of you would have seen before. So here there's obviously been a survey of some kind where people have been asked about their favourite beverage. This isn't a fantastic example really, because you can't tell. This one looks like the biggest, so it looks like cola was the number one choice, but we can't really tell much of the difference between the blue section and the red section. I think red is slightly bigger than blue, and then so tea would be in third, other in fourth, and water in fifth, which is weird because that'd probably be my number one. Yes, so it's good for us to show, okay, actually there's not really much between these top three values. If maybe we had the numbers here, or we were just looking at the numbers, we might not notice that so much, but when it's presented in this way, we can go, actually there's not really much between those three. Here is another one which is a bit more current. So this is something I found from a TV program in America. So this is kind of the biggest COVID-19 worries, and they've done this survey. We haven't really been given much information about how many people they surveyed. It might have been 3, it might have been 3,000, we just don't know. But here we can see that for the people they surveyed, actually for these three options, family getting it, the economy, and getting it yourself, these are actually fairly evenly balanced in terms of the main worries people had, because this pie is split kind of equally between three. I think possibly the economy is slightly bigger, and then family getting it, and then yourself getting it is the lowest one. However, it is it's not really, it's kind of showing us how they're fairly evenly balanced. So today we're going to start looking about how we can construct these. So we're probably going to take 2 lessons on this, maybe 3 lessons on this, because we need to first of all be able to construct them, and secondly be able to interpret them. So we're going to look at one main thing today. And one key bit of information we need relates to this diagram. So see if you can remember what it is that connects these angles. So can you remember? Hopefully we remembered that this represents angles round a point or in a circle, angles round a point, sum to, hopefully we remembered, 360 degrees. Okay, so that's something you should know already. We have learnt it this year. You probably already knew it. And this is something we're obviously going to need with a pie chart, because pie charts are a circle. So we know that a circle is 360 degrees. So if you like, here is my circle. And I know all the way around here, my slices have to add up to 360 degrees. So let's now discuss how to work out how many degrees each slice gets. So here is some information. So say we've been asked, we've done the survey, and we've been asked to prepare a pie chart representing this data. Right, so we need to basically know how many degrees in this pie chart are going to be taken up by the car, how many is going to be taken up by the bus, how many people are going to, how much the walking people take up, and obviously cycling. I know straight away looking, the walking is going to be the biggest segment and cycling is going to be the smallest segment, but I need to know exactly how many degrees is in each section. So the way I want us to do this is, and this is for me a really key skill or a really useful skill in maths, is to work out how much one of something is worth. We've already done this a bit in proportional reasoning. You know that 5 CDs cost £25, so you know that 1 CD costs £5. Kind of that idea, like the whole ratio idea. So here, well, first of all, let's work out how many people were surveyed in total. So see if you can work that out. So in total, we should have got 8 and 12, that's 20. That's 31, that's 36. So 36 people are in this survey. Right, so we know that those 36 people, we have to split them equally, or we have to split that 360 degrees equally between them. Well, like I said, the key bit of information here is working out how much one person gets. So how many degrees is one person represented by? So can you work that out for me? Hopefully we notice. So look, we have 36 people are in total. They're going to have this 360 degrees split between them. So if we divide by 36, or we divide that 360 degrees by 36, we work out how much one person gets. And one person in this case, 360 divided by 36, gets 10 degrees. So each person in this survey gets 10 degrees. Now we know that, well, now I can work out how many degrees there are going to be in each section. So for the car, there are 8 people. Well, each person gets 10 degrees. So if I times that by 10, I know that the car is going to be represented by 80 degrees. Hopefully we can, without too much trouble, work out how much each of them gets, because each one I just multiply by 10, because I know one person is 10 degrees. So this one will be 110 degrees. This would be 120 degrees. And finally, cycling, the smallest section, gets 50 degrees. Can you think of a way that I could now check this? So pause the video and just think, is there a way I can, like a check that I can put in place and make sure I'm doing the right kind of thing? Hopefully we thought, well, if I add these up, they have to add up to 360 degrees. So 80 add 110, well, that's 190. Add 120, that's 310. Add 50 is 360 degrees. Brilliant. That's a little check I can use. And now I could go ahead and construct the pie chart using that. We're not going to do that today. Can you please make sure that next lesson you have got your protractor to hand? So we're not going to use it today, I don't think, but if you can make sure you've got your protractor to hand, that would be really good so that we can draw these pie charts. So for this question, like I said, the key thing here is working out how much one person gets. So how many degrees one person gets. Once we've got that key bit of information, the rest is quite easy because I would just multiply the frequency by that value. So could you please now have a go at working it out for this one? So you don't need to draw the pie chart. I just want you to work out how many degrees each section will be represented by. So pause the video and have a go. Okay, so let's go through the same steps here. So in total in the survey, so this is obviously a survey's been done and people have been asked which rugby team they support. If we'll find out how many in total were asked. So if I add these all up, and you should have found that there were 90 people. Now obviously it's not always going to necessarily be people, but most of the time it's going to be. Right, so 90 people. So I know these 90 people I have to spread out equally between those 360 degrees. So one person, if 90 people are 360 degrees, then one person I would divide by 90. You would work out that one person is represented by 4 degrees. So now one person is 4 degrees, so all I need to do, so for example for here, for 20 people, well each person gets 4 degrees. So England will be represented by 80 degrees. France will be represented by 20 degrees. 15 times 4 is 60 degrees for Ireland. 25 times 4 is 100 degrees for Scotland. And 25 again, it's the same as Scotland, 100 degrees for Wales. Let's double check that by making sure these add up to 180. 80 add 20 is 100, add 60 is 160, add 200, yep, 360 degrees, awesome. If you feel you're comfortable with that skill, please go straight on to the Hegarty video now. If you feel like you need another example to look through, please watch the one on the next slide. But if you're comfortable, you think, yeah, of course that makes sense, go on to the Hegarty quiz and answer the questions on there. But I'm going to go through another example if you need it. All right, so have a go at this one yourself using the work we've done on the previous slide. Right, so first of all, we need to work out the total. So here, well, 25 add 14 is 39, add 21 is 60. So here, we've got 60 people. And so 60 people in this 360 degrees are going to represent 60 people. So one person, well, if 60 people, 360, let's divide both sides by 60, and we should get that one person here is worth 6 degrees. So if one person is worth 6 degrees, well then 25 people, well, each person gets 6 degrees, so we're going to times that by 6, they get 150 degrees. The green portion is going to get 84 degrees. I'm trying to do this in my head. And finally, the red section is going to get 126 degrees. So slightly trickier numbers, perhaps, if we're going to plot, if we were to draw it. Let's add these up. 150 add 84, 234 add 126 is indeed 360. And then I would go ahead and draw that. But today we're just worried about getting those parts correct. So now have a go at that Hegarty quiz.